Now we have a question here. If alpha and beta are any two complex numbers with modulus of beta is 1 and we are supposed to find the value of this. This question is an excellent application of conjugate of a complex number as well as modulus of complex numbers and properties involved with them. So we are supposed to find mod of a combination of complex numbers, which is ultimately a complex number. Since we have to find mod of a complex number, so we can imagine that this is related to something like mod z square. Z is a complex number. Mod z square is the complex number times its conjugate. So if we want to find the value of this, that means something of this kind, first we have to multiply the complex number and its conjugate. Means this complex number and this complex number's conjugate, and then we will come to the value of this. So let us begin. As I solve, you will understand that this is such an excellent question which involves many properties of conjugate and modulus of complex number. So let's begin with this. So because I want to find the value of modulus of this, I should first multiply the complex number and its conjugate. The complex number is this itself. So starting with beta minus alpha by 1 minus alpha conjugate beta. This is the first complex number times its conjugate. That is beta minus alpha by 1 minus this. And its overall conjugate. Overall conjugate means this conjugate will go to the numerator as well as denominator. So whatever properties I'm going to use while solving this question, I will list down them in the right side zone. So the first one is this. I started with this to get the value in form of this, which is our requirement. Second property that we are going to use is mod of z1 by z2. Overall conjugate is mod z1 conjugate by z2 conjugate. So here we will get beta minus alpha by 1 minus this, as it is, this one. And then this conjugate will go to this, all of them. To individual terms it will go. So it is a beta conjugate, alpha conjugate by 1 conjugate. We can write it as 1 only. Then here alpha conjugates conjugate and beta conjugate. So alpha conjugate conjugate. So the next property here involved is the conjugate's conjugate of a complex number is the complex number itself. Now its continuation is the numerator beta minus alpha times beta conjugate minus alpha conjugate. Alpha and beta are complex numbers. Instead of z, it is written alpha and beta. Denominator 1 minus alpha conjugate beta times 1 minus alpha conjugate conjugate is the complex number itself, means alpha times beta conjugate. Now we will multiply the numerator binomial, denominator binomials, term by term. So this times this, then this times this, then this times this, and this times this, the same thing in the denominator. So we'll get beta times a beta conjugate minus beta times alpha conjugate minus alpha times beta conjugate, then minus of minus is plus alpha times alpha conjugate. Denominator 1 times both of them is a 1 minus alpha beta conjugate. Then minus alpha conjugate times beta times both of them will give us minus alpha conjugate beta, minus of minus plus, minus of minus is plus, then this into this, this into this. So alpha conjugate times alpha, beta conjugate times beta. Now the fourth property related to conjugate and modulus we are going to use is this one. The complex number times its conjugate is the mod of the complex number square. So you can see here, you can see here, you can see here, you can see here. In these 4 locations this property is applied. So here we get beta square minus beta alpha conjugate alpha beta conjugate plus mod alpha square. Denominator 1 minus alpha beta conjugate alpha conjugate beta plus mod alpha square mod beta square. So this is how We started from left hand side and we condensed up to this. In the question, we are told that mod beta is 1. So wherever we see mod beta, there we'll write 1. This is also 1. So the numerator is something of this kind, 1 minus beta alpha conjugate alpha beta conjugate plus mod alpha square. How denominator look like? Denominator is also 1 minus see, numerator second term is beta alpha conjugate. The same kind of term is here. So I'm writing this one first. Minus alpha conjugate beta, which I'm writing it as beta alpha conjugate because multiplication of complex number is also commutative. And then I'm writing this one, alpha beta conjugate plus, and here mod alpha square times 1 is mod alpha square. And you see numerator and denominator are same thing, so that turns 1 on cancellation. Now, this product is 1, but this product means complex number times conjugate of complex number. Complex number times conjugate of complex number is mod of the complex number square. So this is 1. So I'm writing here, now since beta minus alpha 1 minus this times beta minus alpha by 1 minus this. So the complex number times the complex numbers conjugate is modulus of beta minus alpha by 1 minus alpha conjugate beta, modulus of the complex number square. The product is this, and this product on simplification turned out to be 1. See, the product on simplification turned out to be 1. So if this part of the video was not visible when I was simplifying, now you have the steps to see. So yeah, now it is visible. It turned out to be 1. So the product is actually this formula and the product value is 1. So this is 1. So now these two are equal. Now this implies mod beta minus alpha by 1 minus this is square root of 1. Square root of 1 is 1. So now what is the value of this one? What the question is about? Beta minus alpha by 1 minus this. The value of this is 1 and this is the answer. And this is a very good question, very good application question that involves conjugate as well as modulus of complex number.